Okay, example 6.1. An AC source V is equal to 500 sine omega t. 500 is peak voltage. V0 is connected across a resistor of 250 ohm, and this is resistance. Calculate the peak current. This is I0. I0 is given by V0 divided by R. So 500 divided by 250, and we get the answer is 2 ampere. This is the peak current. Next question asks the RMS current. The relationship between RMS current and peak current is given by RMS is equal to peak current divided by the square root of 2. And we know the answer for peak current 2 divided by the square root of 2, and we get the answer 1.41 ampere. Next, mean power. Mean power is P average. P average also in this circuit, we have AC source here and connected to a resistor. This kind of circuit, P average is also is same as P dissipated, and P average is equal to IRMS squared times resistance. So we get from the previous answer, square R is 250, and get the answer is 497.03, and the unit is watt. Example 6.2. Figure 6.4 shows a graph to represent alternating current passes through a resistor of 10 kilo ohm. So this is resistance. Calculate the RMS current. So this IRMS. Frequency of the AC. So this F. And mean power dissipated. And this is P average. Okay. We are given the graph. So this is our peak current, and this is one cycle, so that means this is our period. RMS current is equal to peak current divided by the square root of 2. So we just substitute the value from this graph, 0.02. This is the peak value, and we get the answer 14.14 milliampere. Okay, next, frequency of the AC, F is equal to 1 per period. 1 divided by period here is 40, so we just put 40, but be careful, look at the unit here. That is milliseconds, so that means 40 times 10 to the power of negative 3, and we get the answer 25 Hertz. And lastly, average power, which is dissipated power also. And it is equal to RMS current squared times resistance. So we substitute the value. Don't forget the square. and we get the answer 2, and the unit is watt. Example 6.3. A capacitor has a RMS current of 21 milliampere. So this is IRMS at a frequency of 60 Hz. So this is F. When the RMS voltage across it is 14 volt. So this is VRMS. What is the capacitance of the capacitor? So the question asks us to find C. VRMS is equal to IRMS Z. So for this circuit, we draw the circuit. So it's only capacitor there. So that means the opposition Z is equal to XC. So we get here. So VRMS is equal to IRMS XC, and XC is equal to VRMS divided by RMS. So the question asks us to find the capacitance. We can get the capacitance from this reactance capacitor, where XC is equal to 1 divided by omega C, 1 divided by 2 pi frequency capacitance. So that means we have to find XC first. So XC is equal to 14 divided by 21 times 10 to the power of negative 3, and we get the answer 666.67 ohm. Then we substitute here. So C is equal to 1 divided by 2 pi Fxc is equal to 1 divided by 2 pi frequency 60, and Xc, there is our Xc, and we get the answer 3.68 microfarad. If the frequency is increased, will the current in the capacitor increases, decreases, or still the same? Explain. Okay, we know the capacitance reactance Xc is equal to 1 divided by angular velocity capacitance, and is equal to 1 divided by 2 pi frequency capacitance. If the frequency is increased, so that means the reactive capacitance here will decreases, and when the capacitive reactance decreases, it means the opposition also will decreases, and from Ohm's law V is equal to IZ, and if we maintain the voltage, opposition decrease, so I will be increase. So the answer is the current in the capacitor increases. Question C. Calculate the RMS current in a capacitor at a frequency of 410. So this F. So RMS current is equal to RMS voltage divided by capacitive reactance. So that means we have to find capacitive reactance first, using capacitive reactance is equal to 1 divided by angular velocity capacitance, 1 divided by 2 pi frequency capacitance, and we substitute all the values and see the answer from A, 3.69 times 10 to the power of negative 6, and we get the answer is 97.53 ohm. Then we substitute here and we get the answer 0.14 ampere. Example 6.4. RMS voltage 12.2 volts. So this RMS voltage with a frequency of 1 kilohertz. This frequency is applied to a 0.29 millihenry. This is inductor. What is the RMS current? So RMS current in the circuit. So RMS current is equal to RMS voltage divided by Z. So what is the circuit now? So we draw a circuit, the AC source there, and we have inductance. We have only inductance here, so that means Z is equal to inductance reactance, and is given by angular velocity inductance, and is equal to 2 pi frequency inductance. And we substitute all the values are given in the equation. 1000 0.29 milli times 10 to the power of -3. So we get the answer is 1.82 ohms. So that means here we substitute the values divided by inductive reactance. So 12.2 divided by 1.82, and we get the answer 6.7 ampere. Okay, B. Determine the peak current I0 for frequency 2.5 kHz. This is a new frequency there. So IRMS is equal to peak current divided by square root of 2. So that means if we want to find peak current, we have to find first RMS current. So we have a frequency, that means and IRMS we can find using this equation here as previous part, and the impedance for this circuit is X, inductance reactance. So that means we have to find XL first. So XL is equal to angular velocity times inductance, and is equal to 2 pi frequency inductance 2 pi frequency. Now the new frequency we substitute 2500, and then the inductance is given 0.29 times 10 to the power of -3 Henry there, and we get the value is 4.56 ohm. Then we substitute the value, as we know the value of RMS voltage is given 12.2 volt, and inductance reactance we just find the new value, and the RMS current is 2.68 ampere. Then we substitute in this equation to find peak current, and we get the answer 3.79 ampere. Okay, example 6.5. A 2 microfarad capacitor, so this is capacitance, and 1000 ohm. So this is a resistance are placed in series with an alternating voltage source of 12 volts. So this is the RMS voltage and the frequency of 50 Hz. This is frequency. So calculate the current flowing. So this is RMS current. So we find RMS current using this equation. So that means we have to find impedance first. Look at the circuit we draw. So we get two components there like this. So that means we have C, we have R. So that means we have XC. XC is equal to 1 divided by angular frequency times capacitance 2 pi F C. We substitute the value 2 pi F, we have 50, and capacitance we have 2 times 10 power of negative 6, and we have 1591.55 ohm. So these are capacitive reactance. So now we can find the impedance. Impedance for this circuit. So for this circuit we have two components. So that is equal to square root. Since we have two components, so R squared plus XC, capacitive reactance square. So we substitute the value. Don't forget the square. 91.55 square, and we get answer is 1879.64 ohm. Now we get the impedance of the circuit. So we can substitute the value here. The given RMS voltage is 12, so we just divide it by the value of impedance that we just get, and we'll get the answer 6.38 milliampere. Okay, P. The voltage across the capacitor. So the question asks us to find VC, voltage across the capacitor, and voltage across the capacitor is equal to RMS current times capacitive reactance. Okay, so we already get all the values here. For example, this one is 6.38 times 10 to the power of negative 3, and XC we just get 1561.55. Okay, and we get 10.15 volt. C. The phase angle of the circuit. Phase angle of the circuit. So that means we have to draw a phasor diagram. So let's draw. Just now we have R arrow like this is R, and XC arrow pointing downward. So the resultant of these arrows is Z, and this angle is phase angle. So look at this diagram. Here we can see that cos phase angle is equal to R divided by Z. R resistance divided by impedance. Also, from that phasor diagram, you can see tangent phase angle is equal to XC, capacitive reactance divided by R. So we have two ways. Both ways we can use to find phase angle. So I will use this cos resistance. Resistance is 1000. The impedance we just get 64, and we get the answer 57.86 degree. Also, we can change into unit radian. It become 1.01 radian. Example 6.6. So 1.8 kilo ohm, this resistance R is in series with a 0.9. It is our L, and 60 hertz this A, and our VRMS. Calculate the RMS current. So the question asks us to find IRMS. So to find IRMS is equal to RMS voltage divided by impedance. We have to find the impedance first. Impedance that is 2. So this circuit consisting resistor and inductor. So the impedance is just square root R squared plus XL squared. We don't have XL, so we have to find XL. XL is by frequency inductance. We substitute the value. Inductance 9. Get the answer 339.29. Okay, put the values here in impedance, resistance 800, that plus 9 point squared, and we get the value 1831.7 ohm. So we already have the impedance there, so we can calculate the RMS current. Just substitute at 65.5 ampere. Okay, next question asks us to find the phase angle between voltage and currents. Phase angle. So phase angle is equal to cos resistance divided by impedance. Equation already given, right? The values, so we just substitute. And you get the answer 10.68. Please. So if you want to draw the phasor diagram, so we have X, the R is arrow, R, O is XL. This also the arrow for from this for the resistance. So this the impedance Z and this is the angle. So in terms of current, here is the current I. We have here also we have the voltage through this, voltage through conductors, and have this is the voltage there, and this is the example 6.7. Based on the RCL series circuit in figure 6.20, the RMS voltage across R, L, and C are shown. With the aid of the phasor diagram, determine the applied voltage and the phase angle. So the applied voltage and the phase angle. So question asks applied voltage and phase angle. Okay, so we are given the value of VR here, and here is VC, and this is VL. So the phasor diagram, okay, we always start with R at axis. So we have 153, and we have VL going up there. VL is equal to 314, and downward here is VC is equal to 153. So this diagram will become the y, this y axis here. We add them, is VL minus VC, since VL is greater than VC, and here is VR. And here is the applied voltage E, and here is the phase. So the question asks us to find this capital V here and this phase. So how? So the capital RMS voltage V is equal to, from this diagram, is a square root VL VC squared plus VR squared. Okay, we substitute the value V minus 5 squared plus V squared, and get the square root the value, and we get 251.24. And from that value, we can get the phase angle is equal to, from this diagram, the phase angle is, what is the relationship between the distance, voltage across the distance, and applied voltage. So adjacent and hypotenuse, so we got cos, arc cos there, arc cos VR divided by V, okay, and we substitute at 153 divided by 152, okay, and we get value of 52.45 degree. Okay, now we move to question B. The current flows in the circuit if the resistance is given 26 ohm. So the question asks the current flow I. We are given here this VR here, so we can just use your I. Look here carefully, is equal to VR divided by R. So it's not a applied voltage, but this value is given through the resistor only. So that's why we substitute VR here, and we get the value 5.88 ampere there. This is a series, like a series connection series. So that means same current flows in the capacitor, in the inductor. So for question C, the question asks us to find the inductance L and the capacitance C, given the frequency here 50 Hz. So here is VL. So voltage through inductor is equal to the current times the inductive reactance. And we elaborate the formula, and we get inductive reactance is equal to 2 pi frequency times inductance. So the question asks us the value of inductance. So this equation become L is equal to VL divided by I by frequency. So we substitute the value carefully. We just get up there 5.88. Frequency is 50, and we get the answer 0.17 Henry. Next, for the capacitor, so this is the VC. So VC is equal to I XC, and this equation equal to I divided by 2 pi FC. So we bring a C to the title. So the question will be like this: VC 2 pi C. Okay, we substitute the value again. B there divided by VC is given 115, frequency 50 there, and get 1.63 times 10 to the power of -4 farad. Next, the question asks us to find the resonance frequency. Resonance frequency is given by this formula: 1 divided by 2 pi ferrite inductance times capacitance, and we just substitute all the value that we just calculate in the previous question: 0.17, 1.63, 10 to the power of negative, and the answer 30.23 Hz. 6.8, 100 microfarad. So just 4 inductors and 30 ohm resistance are connected in series with an alternating source given by the equation. So calculate the first frequency. So we can get the frequency from this one. it a general equation, not sine times but e. So from here we get frequency and root f frequency divided by, and we get the answer figures. Okay, next turn. Question B asks us to competitive reactance is at D reactive reactance this XL. Competitive reactance X given by divided by turns. So we do 100 there. Reactance is 100 minus, and we get 100 reactive reactance. XL is equal to angular frequency times inductance. We are given 100 there, and the inductance value is 4 Henry, and we get 400 ohm. Okay, next. Question C asks us to find impedance Z. So just now we already have XL and XC, and the equation also given here R. So we just substitute all the value in the XL C squared plus R squared. Okay, substitute. So XL is 400 just now, minus 100 squared plus 35 squared, and I get the value 302.03 ohm. Next, the question asks us to find a peak current. Peak current is I0. Look here, we already have the peak voltage V0. So I0 is equal to V0 divided by impedance Z. 520, and we already calculated a value of impedance 3003, and I get 1.72 here. Okay, question E asks us to find phase angle. Phase angle, this is the symbol of phase angle, and phase angle is equal to hard cos resistor divided by turns. We already have used, so we just substitute. Very simple. This is the R35. We already calculate the impedance 302.03, and we had 3.35 degree, 83.35 degree. And lastly, the question asks us a power factor. Power factor is equal to cos phase angle, and we just substitute the value 8.5 degrees, and we have a 0.1. The power factor, there's no unit there. Okay, example 6.9. 22.5 millihenry. This is inductance. 105, this is resistance, and 32.3 microfarad, this is capacitance, are connected in series to the alternating source. 240, this is RMS. This is frequency. So sketch the question asks us to sketch a phasor diagram. To sketch a phasor diagram, first we have to calculate first the inductive reactance XL, capacitive reactance XC first. The R is given. Calculate XL is equal to 2 pi L. Put the value. Times 10 to the power of -3, and we get the value. I get 7.07 ohm. Same to the capacitive reactance, 1 divided by 2 pi frequency capacitance, 2, the 50 capacitance 32.3 times 10 to the power of -6 micro there. I get the answer is 98.55 ohm. Okay. So what will be the phasor diagram? It will look like this. So to the right is always the resistance. So resistance, and look here, which one is greater? XC is greater. So that means the arrow downward is longer than upward. So this is our XL and this is our XC. So combine these both vertical arrows. So we have distance, and this is our XC minus XL, and this is our distance, and this is our phase, and this is our phasor diagram. Okay, so we have impedance there, so we can calculate the value of impedance. Impedance now is XC minus XL squared as R squared. So I substitute again all the values. 7.07, don't forget to square them, and the resistance is 105 squared, and the impedance is at 139.26 ohm. So look here, this is 139.26, this is 135, and this is inside here. Okay. And then from this value R and Z, we can calculate phase angle here. Okay, let's look what is the next question. The power factor. Power factor is cos P, and from the previous diagram, cos P is resistance divided by impedance. So we can just substitute values. We have already calculated them. So I get 0.75. So that is the power factor. Next, determine the average power consumed. So average power, P average is equal to I RMS V RMS cos this angle, and this is there, and this is a power vector, right? And in the question we don't have the I RMS, but we know I RMS is equal to V RMS divided by impedance. So V RMS here, and this is the power vector there. The substitute all the values already there. So 240 impedance. Just now I calculate 139.26, 240 and 0.75, and get the answer 310.21 unit is watt.